In this video, we're going to cover section 4.3, right triangle trigonometry. This is still unit 4. A lot of this is going to be found in the huge foldable that you should have already started. I'm going to go ahead and show you part of it because it's not complete quite yet. But basically, we will be using tab 1, which is the special right triangles, slightly, and tab number 5, which is the right angle trigonometry. Okay. Here we have a really quick review on something that you know as SOHCAHTOA, and that is basically this triangle, okay, where we have an angle theta and then three sides that correspond. The opposite side, the hypotenuse, and the adjacent side. And the way we use SOHCAHTOA is we know that, here it is, okay, that the sine, okay, so and this isn't stapled yet, but it will be. The sine of this triangle is going to be opposite over hypotenuse. So relative to the angle, to find the angle, you would have to take the opposite side divided by the hypotenuse, okay, and then go from there. The same thing goes with the other three. We have cosine of theta, which is adjacent over hypotenuse, so that's the CAO that we're talking about with the SOHCAHTOA. So that would be adjacent and then hypotenuse. Tangent is OA, so opposite and adjacent. And then you have the reciprocals. Okay, so the reciprocals are basically these ones flipped. So you'll notice that cosecant, which is the same as 1 over sine, is just these two flipped. Secant, which is the same as 1 over cosine, is these two flipped. And cotangent is the reciprocal of tangent. So again, it's my two letters here flipped or two sides flipped. Okay, so we're going to be referring to this foldable. I'm not going to show it every single minute, but hopefully you can follow along with your own. Okay, so using that, we're going to go ahead and do this very first problem that says find the value of the 6 trigonometric functions. So all we need to do for this part is, is write the ratios that go with each of the functions. So by the 6 functions, we are talking about sine, okay, so sine of theta, cosine of theta, tangent of theta, okay, cosecant of theta, secant of theta, and cotangent of theta. And I'm going to use what I know about SOHCAHTOA to fill in the numbers, okay? So first of all, I know that this is my angle, okay? So the side over here, this is going to be opposite of the angle. So I'm going to go ahead and put OPP, which is O for opposite, okay? I also know that adjacent to this one, so let me see if I have a green color here. Adjacent to the angle is the side that's basically the leg that's right next to it. So this one right here is alongside my angle. So I'm going to put adjacent, ADJ, or just A. Okay, and finally, and it's kind of hard to see, but this is the adjacent. And finally, the hypotenuse is going to be, well, the longest side in a right triangle, which is the side that's always across from your right angle. And this is my hypotenuse, or H. Okay, and we're just going to use what we know about SOHCAHTOA. So sine, okay, this is supposed to be O over H, opposite over hypotenuse, is going to be 12 over 13. That's it. Done with that. Cosine is A over H. So we're looking at the adjacent, so 5 over 13. Tangent is opposite over adjacent. If you ever forget, just do this. SOHCAHTOA. That's why it's called SOHCAHTOA. You have the letters that kind of go with it. Tangent is opposite over adjacent, so 12 over 5. So opposite over adjacent, 12 over 5. Cosecant, now these are not part of the SOHCAHTOA, but remember that they line up with them, they're just flipped. Cosecant is the reciprocal of, let's see this one, is the reciprocal of this one. So I'm just going to flip this one. So it would be h over o, which is 13 over 12. Okay, secant is the reciprocal of cosine. So I'm going to flip this one now. H over a, which would be 13 over 5. And last but not least, cotangent is the reciprocal of tangent. So I'm going to flip these two, a over o, which is 5 over 12. Okay, and that's it. That's all there is to writing the ratios that correspond to an angle of a right triangle with the 6 trig functions. Okay, so moving on. Hopefully that was easy enough. Moving on. We have now finding the values of some 3 functions here. For this one, I do have a quick recall. You will find the special right triangles in tab number 2. So here is tab 2. You're looking at these two right here. You have your 30, 60, 90 and your 45, 45, 90. Okay, so just so you know where I'm looking, this is tab number 1, not 2. Tab number 1, special right triangles. Okay, they follow a pattern where you have a 30, 60, 90. Across the 60 is x squared root of 3. Across 30 is x. Across 90 degrees is 2x. The 45 is a little bit easier because these are the same, so therefore the sides should be the same. So x, x, and then the hypotenuse is just x squared root of 2. And you can prove these using Pythagorean theorem and all that. We'll do that later. So the first one is cotangent of 45. So I need to use this reference triangle, 1, 1, square root of 2, okay? So what I'm going to do is I'm going to draw it out just real quickly. So 45 degrees, 45 degrees. This is 1, this is 1, this is 1 square root of 2, or just square root of 2. And I'm looking for cotangent. So since 45 is the same thing, I'm just going to pick one. I'm going to say, let's pick this one to be our theta, okay? So cotangent of any angle theta, according to my foldable, okay, is adjacent over opposite. So we're looking at the adjacent side would be this one, A, and the opposite would be this one, O. So in this problem, it's kind of an easy one. Cotangent of 45 degrees would just be 1 over 1, which is just 1. Easy as that. Okay. Secant, moving on. We're going to use the same triangle. Okay, so again, quick sketch. 45, we'll just do the 45 there. 1, 1, square root of 2. So this would be our opposite. This would be our adjacent. And secant is the reciprocal of cosine. So secant of theta, according to our SOHCAHTOA, let's see, cosine is a over h. So this one is h over a. Okay, so what I'm going to do is I'm going to have to use my h for this one. Is I'm going to do secant of 45 degrees equals the square root of 2, because that's my h, over my a, which is 1. And this just reduces to square root of 2 because anything divided by 1 is itself. Okay, and last but not least, we have cosecant of 45. So again, let's do our reference triangle, 45 degrees, 1, 1, square root of 2. And we're doing and let's see, opposite, adjacent, hypotenuse. Okay, cosecant of theta, according to my foldable, is the reciprocal of sine. Sine is O over H, so this one is H over O. Okay, so cosecant of 45, okay, is going to be my opposite, my hypotenuse, square root of 2, over my opposite, over 1. So in this case, it comes out to the exact same thing as the problem before. Okay, so nothing too crazy. These are kind of simple, I hope. They should be a little bit reviewed because you have done SOHCAHTOA in geometry before and in physics. So that's it for those. Let's do 1, 30, 60, 90. And I did put here in class, I'm going to do maybe 2 of them in class. We'll do 1 right now. So let's just do 1 real quick. So the 30, 60, 90 has an interesting pattern. I like to think of it like 1, 2, 3. So it'll be like this. 1, 2, 3. Where across the smallest one is 1. Across the weird one is square root of 3. And then this is just 2. And of course, it's usually in terms of x if you're actually solving a problem, but we're just basing a regular generic triangle. So we're going to use this one. They want us to find sine of 60. So for letter A, 60 is up here, 60 degrees. So in this case, this one would be our opposite. This would be adjacent, and this would be hypotenuse in reference to 60 degrees. Okay, so let's remind ourselves what sine is. SOHCAHTOA, TOA, so it's O over H. Okay, so sine of 60 would be the opposite, so square root of 3 over my hypotenuse, over 2. And that's it. We really can't do anything else with that. So we are done with that one. And just to kind of give you a little bit of insight into this to see how it all comes together, remember this little foldable here? 60 degrees is the same as pi over 3, right? So if I look at my pi over 3, remember 60 degrees, so we're looking at this one, 60. 60 degrees is the same as pi over 3. So if I look at my y value here, because remember sine is y, my y value is square root of 3 over 2. And that is exactly what I got here. Pretty interesting. There is a reason why. Okay, so we'll look at that a little bit later. Okay. Let's go ahead and move on. Remember, we're going to do these two. So B and C, we'll do those in class. If not, you can go ahead and do them by yourself as well. That's totally fine. Moving on. Example number 4. Just lots of examples for these. It tells us to use tab 2 from the main trig foldable. So I'll go ahead and show you what that looks like in just a bit. It says, let theta be an acute angle such that cosine of theta is equal to 0.96. Find the value of A, sine theta, and B, tangent theta, using trigonometric identities. So we have to use some identities for this one. And we do have them in our foldable. Hopefully you have it written out already. Tab 2, if we look at this one, has all the identities. Well, the ones for this one anyway. We have reciprocal identities, basically the ones we already kind of know that these are reciprocals of each other. We have quotient identities. So these come in handy as well. Basically, tangent is sine over cosine, which makes sense because you're thinking y over x. Okay, cotangent is just the flip of that. And then we have these Pythagorean identities, which are a little interesting. We're probably going to use some of these for these examples. Please take note that the square here, it looks a little weird, but what it means is this entire thing squared. So this symbol right here means sine of theta, and then you square it. Okay, so we're going to go ahead and use these identities to solve some of these problems. Essentially, what you're doing is you're replacing some of what we have with these identities because they are equal. This equals that, and so forth. Okay, so let's go ahead and take a look at cosine of theta. I really can't replace cosine of theta with anything, but I do know that cosine is in this Pythagorean identity here, where sine squared theta plus cosine squared theta equals 1. Okay, so what I'm going to do is plug this in to that identity. So let me go ahead and write it out. We're going to use sine square of theta plus cosine square of theta is equal to 1. Just to see if we can figure out what sine is, because if we can solve this to get sine, I'll have the first answer. Okay, so this is for letter A. Well, I don't know what sine squared theta is. That one I'm just going to bring it down. But this one, remember, this is the same, so make a note here. Cosine square of theta is equal to cosine of theta squared. Okay, that's the same thing. So cosine of theta is equal to 0.96. So 0.96 is going to replace this part, but I still have to square it. So that square is still there, is equal to 1. And you're just going to solve it. Okay, so we're going to figure out what this is using a calculator. because I do not know what that is, squared. Okay, I'm getting 0.922, so this is 0.922. And I'm just going to bring everything else down. And it's just basic algebra at this point. We would subtract 0.922 from both sides, which gives us 0 right here. Okay, so I'm end up with sine squared theta is equal to 1 minus 0.922 is going to give me 0.078. I'll just do 0.078. It's fine, 0.078. We want to get sine by itself because that's the first part, sine of theta. So A was sine of theta. That's what we're looking for this one. Okay, so I'm just going to square root. And that will get rid of that little square for me here. So sine of theta is equal to whatever the square root of that is. So let's do that real quick. And I'm getting 0.28 approximately. Okay, so this is approximately, we'll put the little approximate symbols, 0.28. And it just depends if they're asking you to round to 3 decimals and you round to 3 decimals. But I'm just going to do 2 for now. And that's it for letter A. So sine of theta is this, okay? Letter B is tangent of theta. And what I know about tangent is it is one of the quotient identities. So I really do got to staple this at some point. The quotient tangent is sine over cosine. So I can rewrite tangent using this fraction here. So I'm going to do that. I'm going to write this as sine of theta over cosine of theta. And the reason I'm going to do that is because I know what cosine is. This one is just 0.96. That's what it says up here. And this one is right there. So 0.28 divided like normal. So I have 0.28, 0.96, and just divide it. And I'm getting 0.292. So I'll do 3 digits for that one. So 0.292. is approximately tangent of theta. And that is it for this problem, for these 2 problems. Okay, so again, your tab 2 has these identities and you're foldable, so make sure you do have that. Let's look at one more. And I think that might be it for this one. Oh no, we have 2 more. Well, actually, let me see. No, this one won't take long. So example 5. Let theta be an acute angle such that tangent of theta is equal to 2. Find the value of A, cotangent of theta, and B, secant of theta. So this one's going to be the easy one because cotangent, according to my reciprocal identities, is the same as, let me go ahead and rewrite this. This is the same as 1 over tangent of theta. So since tangent of theta equals 2, this is the same as 1 over 2. And we're done. Yay, that was quick. Secant of theta is a little bit more complicated, not too much, but we're going to use one of the Pythagorean identities. So kind of like the one we did before, we had the sine square one. Notice that the second one has tangent and secant. So we're going to use the second one. 1 plus tangent squared theta equals secant squared theta. Okay, so 1 plus tangent squared theta equals secant squared theta. And it's going to be real similar to the one before where we just, plug this in and then solve. So 1 plus tangent is equal to 2. So there's my 2 squared equals secant square theta. Well, this right here is just going to be 4, right? 2 squared is 4. Okay, 1 plus 4 equals 5. Just like the one from a few problems before. We're going to square root to get rid of that little 2 here. And secant theta is going to be the square root of 5, whatever that is. And I'm going to leave it like that because I don't really have to do anything else with secant, so we can leave it as square root of 5. If you want the approximation, you can go ahead and plug it in. Again, it just depends on what you're looking for. If it's asking you for you to round decimal spaces, then definitely just plug it in, get the decimal. But that's it. That's it for those two. Pretty cool. Huh? Identities are pretty cool once you know how to use them. Last one. This is the last one. Example 6. It does say proofs. This is kind of like what proofs look like. It says use the trig identities to transform the left side of the equation to the right side. And we're assuming that our angle is between 0 and pi halves, okay, just so everything is defined and all that. So basically, I want this side to come out to secant theta using identities, okay? So this is all about those identities. I'm going to work with this one first. Okay, I know that tangent, so I'll do this one first. Tangent is the same as sine of theta over cosine of theta. So everything I do in pink is going to be basically the rewrite. So let's do this one step at a time. Remember, this side doesn't matter. This one's going to stay the same. I'm trying to get this one to look like this one. So far I have sine over cosine. I'm going to go ahead and change cosine now. So this one, I'm going to leave it the same now, sine theta. And we can do it in steps. There's step 1, here's step 2. I'm going to change cosecant of theta now. So cosecant is the reciprocal of sine. So I can write this as 1 over sine of theta because they are the same thing. If you don't believe, you can't really see that color. Let me get a different one. Let's use this one. There we go. 1 over sine of theta. And if you don't believe me, just look at your identities. They're there. So here we go. Cosecant is 1 over sine. Okay, so there it is. And this is all supposed to equal to secant of theta. All right, so what can we do with this? Well, I can see that my sines, I have one on top and one on the bottom, so we can do that. So we're left with 1 over cosine of theta equals secant of theta. But didn't we find out earlier that this is the same as secant? I think we did. And again, if you don't believe me, check your foldable. Okay, so we are done. We have proved that this is equal to this. Okay, we're going to do one final one. That'll be it for this one. This one looks a little more complicated just because of all those cosecants and all that. So what I'm going to try to do with this one, just because I do see I see two binomials, like I see this times this, and each of them has two terms. So I'm going to FOIL this and see if that's going to help me at all. So let's FOIL it and see what happens. Cosecant times cosecant is cosecant squared. Remember that we put the square in the middle. It's just the way it's written. Okay. Cosecant times minus 1 is minus cosecant theta. 1 times cosecant is plus cosecant theta. And then 1 times negative 1 is minus 1. And all this equals, oh, remember, we're just looking at the left side. All this is going to equal to that. I'm just going to bring it down like that. So I notice that these two are going to give me a 0, which leaves me with cosecant square theta minus 1 equals this guy over here, cotangent square theta. So I think, if I remember right, that actually is one of the properties. So let me go ahead and look. Let's see, Pythagorean identities. I have this one, 1 plus cotangent square equals cosecant square. So I can maybe mess with this a little bit. Let me see. I have cosecant. So what if I replace cosecant square with all of this? 1 plus cotangent square theta. Let's try that. I'm going to replace this one with 1 plus cotangent square theta. There we go. Bring down everything else. Minus 1 equals cotangent square theta. Okay. And then we can see that the 1 and the minus 1 can give me a 0. So I'm left with cotangent square theta is equal to cotangent square theta. And we're done. Okay. You wanted to do this in steps. This was step number 1 to FOIL it. This was step 2 to just, actually, step 2 is just to rewrite it. And then step 3 was to rewrite this in terms of the identity, get rid of the ones, and we're done. That's it, guys. That is it for this video. Hopefully it was not too long. Any questions, as always, let me know.